earlier when you were talking you about the human in the loop. Do you think we're getting closer to where you'll see an AI agent actually taking actions, or is that something that you would be hesitant about?
At least in the production, in industrial automation, I don't see agents which will be responsible for making isolated decision because it's rather critical sphere. They can give advice, they can highlight something, but I don't believe that we will see in I don't know 5 years, not five, maybe in some kind of small area, 2 years, independent agents, because yeah, on one hand, it's rather conservative sphere of industrial automation and nobody will allow to use, I don't know, fully independent agents. But I believe that they can be used as a good advisors for uh, with let's say with high involvement, with a high trust from operator side, from domain experts.
Hi, everyone. Welcome to the Impact of AI Explored. This episode, we have Nikita Golovko. Hi, Nikita. How are you doing?
Yeah, hi, hello, nice to meet you all. Yeah, I'm fine, thanks. Thanks for this invitation, and yeah, I suppose we will have a rather interesting talk, and yeah.
Nikita, thanks very much for coming on the podcast. Can you just tell me a little bit about what you do on a day to day basis?
Yeah, hello, my name is Nikita, as you know. Yeah, so currently I work for Portfolio AI Architect in Siemens almost for 4 years, and I'm mainly responsible for bringing AI to the factory floor, from training models in the cloud, how to deliver these models to the factory floor, to the edge devices, how to run these models in some kind of limited hardware and software environment, how to retrain, how to collect data, let's say how to provide this closed loop AI for factory automation.
I've just added one question, which was if you saw we put a post up on LinkedIn and someone asked a question. So
Mhm.
it's just, uh, it says, what challenges come up most when you're hiring for industrial AI roles? Seems like scaling would create some unique talent gaps.
Yeah, mainly when we are bringing AI to the shop floor or to the factory floor, to the production, the main challenge, we need to find a person who will be a translator between AI world, machine learning world, domain specific. And it's not about hiring more data scientists, hiring more, I don't know, engineers. It's try to find this maybe a person, a talent who can bridge this gap in understanding, bridge this gap in different silos, in different languages. Try to find these motivated persons, because it's not easy to find a guy who would like, or maybe a woman who would like to do this job. And maybe it's to some extent also about finding a proper architect. Nowadays, it's everybody's talking about AI. Maybe we can name this role, this person, as a real AI architect,
Hmm.
the real AI problem solver. In any case, I suppose in solving any kind of problem, you need to find a problem solver. You need to go away from naming some kind of, I don't know, roles and responsibilities. You need to find a better team player, a better, I don't know, problem solver. It, from
Hmm.
my perspective, it's a crucial and the key idea you when you're trying to find new colleagues.
Great.
Hope to answer your questions.
Great. Just to get us started, Nikita, what is the biggest thing for you that breaks when AI leaves the test environment and then it hits the real world?
The biggest challenge is this different environment, because when you build AI in the laboratory, so to say, prototype, your solution works in some kind of synthetic environment with, for instance, some kind of stable lighting conditions, with clear and labeled data, without any interferences. And when you try to try to bring the same AI solution to the shop floor, you face a lot of problems with unstable environment, different, I don't know, lighting noise, uh, bad data, data shift, even with not desire to understand your system from the end user perspective. Because when you design your system in a laboratory, you have several hypotheses how your system will be used by, I don't know, domain experts, by end users. But unfortunately, when you see how your solution, how your component is used, it's far away from your, I don't know, initial hypothesis. This is two
It's
different worlds where live real production and AI from the laboratory.
yeah, so it's the same as it always has been. The developers think about a way it's going to be used, and then it's get to be released in the real world with different problems, and not really always skilled users controlling the thing.
Yeah, exactly. But the biggest difference between classical software and, for instance, building AI solutions, in classical software design, we are as engineers are more or less able to contact our end users to check our hypothesis. But when we are building AI solutions, sometimes it's rather difficult to talk to domain guys because they are far away from you, or at least you are talking different languages. For
Yeah,
instance, you speak about precision, recall, and all these data science metrics, or maybe some kind of software architecture metrics. But these guys are talking more about some kind of, I don't know, delays on the production line, level of defects, and so on. That's why, again, you need some kind of translator in between who understand, on one hand, the world of data science, the world of software engineering, and on another side, what is really happening in your business process in this production line, or where you would like to put your model.
That makes sense. So, if you're looking at, is there any thing you kind of see with software teams where you think, oh, I'm seeing the same kind of problem over and over again?
Yeah, maybe this lie, this message, we will fix it later, we will test it only in a one pilot. Uh, this later never comes. At the end of the day, we have these ugly solutions used in a production line. This, let's say, pilot used as a part of our industrial production line, and we are always in a hurry. Nobody knows how it works. Everybody afraid to touch this component, to change this component. It's some kind of, this Ouroboros, snake eating its own tail.
Yeah, yeah,
You,
yeah.
yeah, yeah.
Yeah, no, 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 no. We've seen it enough in our own jobs that, a pilot and suddenly it's, the production system, and you're like, what? It's
Yeah, yeah,
like,
exactly, exactly, exactly.
okay, we're doing this. Okay, this
It's
is gonna
live.
end
Oh,
badly.
nice. Yeah.
Yeah, yeah. So, how? What are kind of your early warning signals when it comes to kind of technical debt? Is there anything you kind of see where you go, oh, we're putting on a lot of technical debt even at an early stage?
Yeah, for instance, the same pattern when you hear that don't touch it, your team afraid of changing some kind of component, some kind of piece of code. So don't touch it. It's a first signal, first trigger. The second one, when we have so-called knowledge silos, when only one person knows how this works, or maybe, I don't know, team knows how this component works, and you don't have enough documentation. And yeah, maybe it's two main, I don't know, initial triggers we should consider when we're trying to find weakness in our solutions, trying to find the potential sources of technical debt. Yeah, for me it will be.
Um, um, and what's kind of the one big decision that teams would likely make that cost them later? Is it that they just feel that they're going to go and fix that later? Is that the biggest one, or
Yes, but I would say the most critical will trying to neglect abstraction for external dependencies. It also closely connected with we will fix it later. For instance, if our team is or somebody's team is developing some kind of component which consumes external API, it's much easier to embed these API calls directly in the code base. Again, we will fix it later, we will do it better later instead of building a respective adapter layer to work with different APIs. And suddenly, 6 months later, when we need to work with 500 APIs, it's impossible to change this code, impossible to change this component. It's again about uh, this fear to touch something, to break something, and it's again some kind of infinity loop. We provide an ugly decision we need to maintain, but we cannot maintain because it's
So we're all quite aware of generative AI, but in kind of in an industrial sense,
Mhm.
what are you working with different models, or what's the kind of noticeable differences between what we would see in, like our browser, whether ChatGPT, Claude, something like that, in
Mhm.
comparison with the models or that you're working with?
So mainly, we are working with, so to say, classical machine learning models for time series prediction, for computer vision use cases. And my opinion that generative AI, it's of course a cool things, but it's rather far away from real usage on the shop floor because it's too probabilistic. It's you cannot, for instance, you cannot use a model which you cannot which behavior you cannot predict, which behavior you cannot explain. It's the first aspect. The second aspect, they're still rather high weight to be used on a limited environment. Maybe at the moment, how I see generative AI for the factory use cases is maybe to create some kind of documentation, again
Mm.
together with the user, or maybe to generate a synthetic data, because data problem is another big problem for industrial environment, because either you don't have enough data or your data does not represent the use case you would like to automate with AI. That's why this direction of making a synthetic data with the help of generative AI looks, for me at least, relevant as a use case for GenAI for the industrial automation.
So what you're basically saying is essentially the models you're working with are far more predictable.
Yes, in comparison with generative AI, they are they are more predictable. But again, in comparison with traditional software, they are still a probabilistic, and we need to bridge this gap between deterministic and the probabilistic worlds to have some kind of, let's say, workarounds and safe loops,
Mm.
not to bring a damage.
But
Mm.
so would you put the same kind of safeguards in place, where that be RAG or guardrails? That's all necessary for working with the models you're working with.
Yeah, exactly. So, for instance, when we put in a model to some kind of industrial production use case, we need limitations. We need some kind of maybe sometimes rule-based system on top of this AI, and this rule-based system should also be responsible for, let's say, checking the health checks of this AI model. And at the end of the day, this system should be responsible. This system, together with a human in the loop, should be responsible for making this decision how we should proceed with this or that product on the production line. Which at the end of the day means that the end purpose of AI is not to replace operators, not to replace user, but to help, to give additional knowledge, to give additional advice, to support them in this process of making decision.
Okay. Yeah, no, that makes sense. That makes sense. Okay, so we're talking
Mhm.
about more predictable models, same kind of guardrails, safety measures put in place,
Mhm.
and it's very much to kind of augment the people working on the shop floor. Yeah.
Yeah, exactly,
Okay.
exactly.
And this may sound like a silly question, but are they interacting with robots and stuff, or is it just pure machines, or how does that
It's
kind of work?
mainly it's mainly machine to machine communication.
Hmm.
At least in our department, of course, there are a lot of different use cases
Sure.
when AI is interacting with some kind of robotic arms. But at the end of the day, robotic arms it's also a machine because under the hood, these robotic arms has a software system or some kind of also real time or deterministic system which is controlled by physical signals. I don't know, high, low level.
Yeah, sensory data.
Yeah.
Yeah. And you said that you're running these AI models locally on the shop floor in, I
Mhm.
think, embedded hardware. Uh,
It's edge devices. Yeah, it's to some extent. Yeah, it's embedded hardware. It's edge devices. Yeah. Mhm.
yeah, but what kind of things are you running it on? Or are those Raspberry Pi ish capabilities or
No, I don't want, let's say, to promote any kind of
no, no,
vendors,
no.
but since I'm a part of Siemens, I suppose it's some kind of standard approach for several vendors. So Siemens has its own edge ecosystem. It's maybe that Siemens have PLCs, programmable
Mhm.
logical controllers. It's another variation of Siemens hardware. It's IPC. It's industrial computer which has a Linux operation system, uh, also Edge operation system. It's just a small computer
Mhm.
which under the hood has physical inputs and GPU. It's
Okay.
you can think about it like a Raspberry Pi, but production ready with all this, let's say, additional
Yeah.
hardware enforcements in order to be used in the production use
Yeah,
cases.
exactly. I was thinking about how you can run the AI locally, so you're using the GPU to run it on these
Yeah,
embedded
exactly,
devices.
exactly.
Sure.
Yeah.
That's
Okay,
cool.
so these are all it. This is not a centralized model. It's a local model running on each machine, or it is a
Yeah,
centralized model.
no, it's a model which trained by data scientists in the cloud or any kind of environment. At the
Hmm.
end of the day, this model is deployed to this edge device and it runs locally and responsible for a concrete task for a concrete use case. For instance, prediction of time series prediction. When do you need to perform a next repair for your engine or some kind of, let's say, prediction, classification, defect detection, all these let's say more or less classical applications of ML and AI, not generative AI.
No.
No. Um, is there anything you see where there's kind of one practice that when people are implementing these industrial AI models that
Mhm.
you've seen people skip, and it's gonna like there's going to be after effects because of it?
Mainly the biggest problem when everybody is building AI solutions, not even models. Uh, when teams try to hard code models as a part of business logic, which at the end of the day make it rather difficult to replace model, to retrain model, to test model with another, I don't know, data sets with another hypothesis. So the biggest mistake is try to implement it as a big ball of mode where model works together or hard coded, closely coupled with business logic. It's the biggest architectural issue.
Excellent. Okay, so when we're talking about architectures and team structures, do you see teams like fighting the architecture, and what kind of friction does that create?
Yeah, rather often. For instance, this classical conveys law, and as a classical example, I can give I like microservices. as a classical example, when you, as an architect, design a super cool system, microservice based, but you have only one platform team which is responsible for this implementation. So you have on one hand services which should be deployed, developed independently, delivered to the production line independently, but on the other hand, you have this still monolithic team which implement microservices. And at the end of the day, you don't have benefits of microservices because you have the same mistakes, the same errors, the same bottlenecks with one solid team. It happens when you neglect org structure of your company, business processes which happening inside your company, these hidden dependencies between teams, hidden dependencies between, I don't know, components. That's why you need to design an architecture which works with human behavior, but not, let's say, not contradicting this human behavior. It's about Conway's law mainly.
And for you, what has the biggest impact? Is it code change or is it team structure change that are going to have a bigger impact?
For me, it's team structure change. For instance, I can give another example. There is a data science team which is responsible for building a model which should be delivered to the production line. But since everybody in this team is only data scientists, they create a model, they propose this model to IT team, which is responsible for deployment. IT team just rejects this model because it's not production ready. It's infinity loop, and we will never and ever see this model in the production line. As a solution, we can create a cross-functional team consisting of data scientists, DevOps, MLOps, domain experts, which can collaborate, which can create not a model, but a solution. It means that at the end of the day, it does not change any code. We change our approach, we change the team, which brings us to a rather quick solution and rather quick bringing model to the production.
Well, that also takes a toll on the team because they have to change the way you work, change the way you deliver, change the way you architect.
Is by changing team, which we make this shift in the mindset of a team. Instead of data scientist team, we have a cross-functional team, and in this team we have experts or guys who work with a specific topic, and working together they can enrich the team in total and can bring a solid and let's say complete solution,
End-to-end solution for a problem.
Yeah. Exactly.
Okay. So just to look at I've been reading into some of the stuff you said. And when you say sustainability in system design, what are you actually referencing?
So it mainly means I can also give 2 examples. One example from classical software architecture. In this case, sustainability means that you should be able to support the same system in 2 years with the help of different colleagues, with different team. It means that a new team member will be able to figure out with all the sophisticated stuff in a weeks. You can debug this solution, I don't know, in the night. And in case of building AI solutions, sustainability means that you should be able to retrain the same model again in 2 years or after some time with the help of another data scientist, with the help of another team. This model should be transparent and understandable for any kind of team members, any kind of teams you have in your company. It means sustainability from my perspective.
Now that makes sense. But and does that differ with traditional architectures and AI architectures?
I don't see any differences. I just give 2 examples to highlight because for me, architect is a guy, as I already said, who are solving problems, and it does not really matter in which sphere you are solving problem, in a sphere of building AI specific solutions or building classical enterprise architecture. You just need to understand the real pain of your customer. It does not really matter who is the customer. It's a guy or person who needs your system the real pain and try to solve this problem with the help of different tools. And AI and all this stuff, it's just another tool in your box.
Yeah, that makes sense. So, where do you see the development of AI in industrial sense? What do you kind of see the next evolution of AI? AI.
I believe that AI should be will be widely used to help operators to make a better decision, to predict what will happen with this or that. I don't know, production line. It's a, let's say, more way for classical AI. And for generative AI, I believe that it should be more involved in documenting, in let's say, building this knowledge level on top of already existing production lines, because it's another challenge. We have a production line, we have different data sources, we have all this distributed knowledge, and we need some kind of tool which can collect this knowledge in a way this knowledge exists and build this, I don't know, layer on top. So for this role, I see generative AI can be, I don't know, widely used, and I believe that it's a good direction for future improvements and future use.
You
So
mentioned earlier when you were talking about the human in the loop. Do you think we're getting closer to where you'll see an AI agent actually taking actions, or is that something that you would be hesitant about?
At least in the production, in industrial automation, I don't see agents which will be responsible for making isolated decision, because it's rather critical sphere. They can give advice, they can highlight something, but I don't believe that we will see in I don't know, 5 years, not five, maybe in some kind of small area, 2 years, independent agents, because yeah, on one hand, it's rather conservative sphere of industrial automation, and nobody will allow to use, I don't know, fully independent agents. But I believe that they can be used as a good advisors for uh, let's say, with high involvement, with a high trust from operator side, from domain expert side. But yeah, not
Not actually
working
taking any
alone.
actions, just
Yeah,
advising. Yeah,
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 yeah.
yeah. No, and in fairness, though, myself and Gurjan, we've talked about this before, and that's kind of where we are with AI agent as well. Like, I've seen in my area of end user computing. I've seen some of our competitors looking at like autonomous AI agents, and it actually scares the daylights out of me. I'm like, that just seems like a recipe for disaster. Something's
yep,
going to go
exactly.
wrong at 2 o'clock in the morning, and who's responsible?
Yep.
So it just seems a step too far at this moment in time. I like what you said about the whole AI advisor. I think that's where we are at the moment. Advice, human in the loop, human takes the end action. And you know, you're saying in industrial sense it's quite conservative, but I think we're seeing it across the board, because we're not seeing massive amounts of kind of AI agents. But there's been a lot of kind of hesitation now by companies, because they just don't know what's going to happen. So they're not. So a lot of projects are stalling around AI agents.
Hmm.
So I definitely think we're kind of in the phase where it is about an advisor role in kind of any AI. Essentially, I
Yeah, yeah,
wouldn't
and
even. Yeah.
it's also about traceability, because at the end of the day, if human is responsible for making decision, human knows context better. Of course, we can log, we can document the context
Mm.
where this and the environment where this agent is working, but it should be about traceability, because in this year and next year we will see this AI UA Act, which should be applied in at least in European Union, and this AI UA Act says that any kind of system which has AI under the hood should be transparent from the decision it makes. It should have enough documentation. So you as a user of this system should be able to say this system made that or this decision because of this context, and when it was making this decision, it takes several steps, and these steps are also understandable and transparent and explainable for, I don't know, for everybody, for experts in this sphere, and for
Yeah, and
Mhm.
and and that was another point. I think I was in a LinkedIn post I put out, but it was basically saying, like, it's all very well talking about AI agents. If you like, as you said, you have to be able to show all of those steps. You better have all
Mhm.
your processes mapped out step by step by step by step, because otherwise something's going to go wrong. So I think it's an excellent point about how, yes, you can have them in advisor role, but it has to be clearly defined and documented what it's going to be implementing.
As long as
Exactly.
the party delivering the AI solution is not accountable for the things the AI does, or the AI can be held accountable itself, we still need to be in control.
In any case, it should be in control, because even if AI agents will work for AI, let's say AI environment, we cannot isolate ourselves, or we cannot isolate this environment from our reality. It should be on some level controlled and checked by human beings whether it's okay with physics, with all these things happening around me. Is it legal? Is it, I don't know, okay from the, I don't know, bias perspective, and so on, so on,
Yeah,
so on.
exactly. Yeah, yeah. We still need to have the latest say, the last say.
Yeah,
And
in
and,
any
and
case, I don't believe that machine will will replace us, or I don't know.
no, not quite yet. I was thinking you're doing a lot of industrial AI solutions, your floor AI. Was there one time where you saw something happening, or that you had an idea and you built it in it worked, that you thought, wow, that was awesome? Some
Uh,
epiphany that you had, ooh, that was a cool thing to build, or that's a cool thing to see being
in any case,
working.
it's a separate magic when you it's two different stories. When you create a software architecture, when you create a software, and when you create some kind of code which runs on the hardware, and you really see that your code is moving some kind of physical parts. I've faced this idea maybe first time when I was a student, and I wrote my first program for PLC, and I saw how it physically works. It was incredible. It inspires me. But in any
Yeah,
case, it looks interesting when you use a code to work with physics around you, with things around you. It's really something interesting.
yeah, making stuff move by just something you wrote and not being
Yeah,
hands-on.
exactly,
Yeah,
exactly. You
yeah,
see this magic, how you just write a code, and something, I don't know, some kind of physics. How this
yeah.
code affects the physics around you. Yeah, it's really cool.
And what's your opinion then when it comes to AI assisted coding? Is it something you practice, or is it something you're wary of, or have you enough understanding that it can actually be beneficial to you?
It's a tricky question. At least I'm using AI as a code assistant to give advice. For instance, I have an idea, I need to build a prototype. So it's good for building prototypes, at least
Yeah.
for me to check ideas, but I'm not ready to deliver this code to a production, because if you have a vibe coding, you need to have a, I don't know, not vibe testing. You need to have rather painful testing, but it's cool from, I don't know, checking hypotheses, finding better code examples. But yeah, at least
Yeah,
I'm not using it for the production code.
yeah, no, I'm not saying anyone should. We've said that before.
Yes, it's again about who is responsible, because it does not. At the end of the day, even I just copy paste code from Claude and commit it to the working branch. At the end of the day, I am responsible for this code. And again, about responsibility, and
Yeah, but as you
rather
said,
challenging.
yes, of course. But as you said there, it is the time to get up and running with a prototype is now, it's so quick because you can utilize AI assisted coding, and you don't have to wait weeks to build a test environment and all that. You can just have it, like, I mean, Gerjana played around with, we've built things in a couple of minutes and stuff like that. They weren't good, but we built
They
stuff.
worked.
I would say it's good if for major engineers, if you already write in the code, if you know how it works, it will help. But it cannot be used as an entrance way to become a programmer, because it's about
Oh,
physics. If you don't learn physics in the school,
yeah.
you can use anything you want, but you don't understand the basics. Likely the same. If guy
Yeah.
is not
No,
engineer.
I'm not a coder or a programmer. I just was playing around with it and I was impressed, but I wouldn't
Yeah.
build any kind of productionized system because I would do something wrong. There'd be a massive security hole in it or something like that. Whereas you would be able to go look at the code and go, there's where the security hole is. That should, there should have been a line of code there that stopped that. I and other people similar, because I read about all these people. Oh, I'm building like all these apps. It's like it was like that that whole Clawbot thing that
Hmm.
Mm.
recently. Do you know what you're doing? That's you're installing a server on your device. That server is then broadcasting over the internet, and with certain applications that
Exactly.
hackers, black and white hat, have access to. My friend's a white hat, and he told
Hmm.
me about this. You know, they can see your computer.
Yeah.
You're
Um,
broadcasting to the world, and you have already just given that thing access to potentially your data, your credit cards.
Yeah.
That thing is
Facebook login,
yeah.
yeah.
etc.
It
Yeah.
does. It doesn't matter
Socials.
what it is, but like
No.
just the people I know were like, "Oh wow, yeah, I really want this powerful AI agent," but have absolutely no idea what this powerful AI agent is capable of. And again, it's similar to the AI coding thing. People don't realize the consequences of their
Yeah. Yeah.
actions, and as you said, they really do need to
Exactly.
understand that.
Exactly. What I'm definitely doing, I'm highly using AI as a sparring partner in my thoughts. For instance, I
Sure.
have this idea, just change or the same approach with the coding. So I have this, I don't know, small
Mm.
code. Just tell me whether it's good or not, how it can be improved. From this perspective, it's rather good. Like some kind of, I don't know, different opinion, different mind, but just do it instead of me. No way.
No, no, I think that's fair, and sensible, because there's not a
Exactly.
lot of sense when it comes to AI sometimes, and thinking of the security consequences of this. Everyone's like, "Oh, this is really cool," and then you're like, "Do you know what that actually does?" Because you should really take a step back. So I think that's a broader thing about AI is we all have been guilty of getting caught up in the hype, but we do need to realize the consequences of these things.
Hmm.
And I think we've banged this drum quite a bit, in fairness, but it's no harm to do it again, to be honest, because we're going to see more and more stuff coming out that will get more and more power, and you need to decide how much power and access these systems have.
At least you as an engineer should be responsible for the environment around you, because, for instance, I remember this phrase from Steve Jobs, who said that if I see some stuff around me, I believe that a smart engineer built this stuff. But nowadays, with this AI approach, it becomes rather dangerous. That nobody, let's say, I have rather zero confidence that this is really well designed. That's
Mm.
why, being a good engineer, I'm trying not to make these mistakes, not to make this, I don't know, silly decisions only AI based. Just to also promote this approach that uh, before you make a decision, before you, I don't know, it's not even about using AI or not. Before you make any decision, you just need to have this trade-off. You need to understand that it should be used by somebody else, whether it's safe. You should put yourself in the shoes of your consumer. It's much wider than AI topic.
Yeah, those are more fundamental questions that
Yeah,
you're looking at.
Yeah. No. They're fundamentals in as you said, in the wider world, not just in AI, in terms of how you handle your access and information.
exactly. It's, let's say, it means as much power we have, as much uh, thoughts, as deeper reflect we should, because having this power, having these capabilities, we should be rather careful. We should, I don't know, reflect what we are doing and think with it. Yeah, just maybe it's a good exercise having this power to have more reflection. But yeah,
Yeah.
Don't always go hand in hand.
yeah, exactly.
Excellent. Well, this has been a really good discussion. And it's been interesting to hear kind of the kind of key differences between generative AI and industrial AI, because it wasn't something I was completely aware of when we started this. So um, just to kind of close out, in terms of, obviously, we've talked about software systems and AI systems and technical debt, and we've all seen technical debt. So
Mhm.
if you were going to kind of say one key thing to reduce future technical debt, what would that be?
Try to document your decisions. Try to document uh, your decisions. Document how things around you is working, especially when you're involved in these things. How your architecture is working, and try to explain. Try to figure out. Be curious. Try to document, and then having these documents, having this traceability, you will be always able to answer a question why it was designed, whether it was intention decision to have a technical debt, to have some kind of trade-offs. Just to, and even if you let's say it sounds good for so-called greenfield projects when you have a ability to design something from scratch. For brownfield, it also, you can just pick one component, something, let's say some kind of component everybody is afraid to change, afraid to touch, to figure out, to document how it works. Dependence is what's under the hood, and who knows, maybe it can help your company to decrease technical debt, or maybe more to be more consciousness about decisions and uh, things you are building.
Excellent. Nikita, that has been fantastic. Thanks so much. Thanks also to James Davey for our listener question. It's a section we're going to try and feature on every episode going forward. So we will see you on the next episode. Thanks very much.